Hi everyone. In this video, I will continue about the discussion of differentiation. In the previous video, we already discussed about the limit function to introduce you about differentiation, using the first principle method. If you haven't checked the video, you better to check the video first. I will put the link in the description, so check it out. And in this video, I will continue about how do we work on the differentiation. How do we derive the function, and especially about the rules of differentiation. So let me start with the definition of the differentiation. As you know, the differentiation is a technique that we use to find or to check the change of the quantity. Some of the applications in real life problem, such as you can predict or you can find the heat transfer during the conduction to the materials, like if you see in the picture, if there is a heat from inside and it's conduct from the wall, so you can find the rate of the heat transfer from inside to outside. We know that, yeah, wall is an insulator, but it still conduct the heat. Yeah, maybe the rate of the conduction very small, so we can still consider it as insulator. But yeah, mathematically, if we want to find the rate of the heat, yeah, we can use the differentiation. Like you can say the equation there, it's dq over dt. Now, the dq over dt is the symbol of differentiation. So you see the difference, yeah, the change of q with respect or to the change of time. So this is one example of the differentiation. The other example is if you want to check the magnetic field around a wire, you can use the equation containing the differentiation form. So dB. So we consider about the change of the magnetic field to the effect of the magnetic field at the whole region. So that's about the explanation about the example, the real life situation about differentiation. Now, now let's see the differentiation as the tangent of the curve. In the previous video, we see the differentiation as the change of coordinates, the change of the point. How do we find the change of the point using the differentiation? Now we will see the differentiation as the tangent to the curve. Yeah, basically, this is the same thing. So if I have two coordinates, I can draw a straight line. Now, to find the tangent, that means I have to move B close to A. So I have a tangent at point A. Now, if you want to find the gradient of the tangent, so we know that the gradient of the tangent is m. This is rise over run, yeah, delta y over delta x. while the delta y is fx plus delta x minus fx over delta x. So if you notice that this notation is similar or exactly the same as the equation that we discussed in the previous video. So better for you to check that video first. Yeah. So if I draw here, we have the graph and we have the two coordinates to find the tangent. So this is x and this is x plus delta x as the delta x for the separation. So that means the y value of this is fx and the y value of this is fx plus delta x. So the gradient is the rise over run. So if I zoom this area, it will become fx plus delta x, fx. So this is delta x, yeah. So the rise is this, fx plus delta x minus fx. And the run is the delta x. So we can rewrite as this expression. Now since the difference of the delta x are small enough, so it's approach to zero. So that's why we have to use the limit notation. Yeah? Limit for delta x approach to zero of the delta y over delta x is a differentiation dy over dx, or we say dy dx. Yeah. So in here, that the gradient of the straight line, in this case, is the tangent to the curve, is a differentiation. Yeah, dy over dx. So we put to the formula. So dy over dx equals to limit delta x approach to zero of the rise over run. Yeah, this is the delta y and this is the delta x. Now this method known as first principle method. Yeah, we already see this form in the previous video. So again, please check the previous video so you can understand this better. Now, how do we work on this formula? In previous video, we already discussed about this formula, about the first principle method. But now, let's see to the equation. What is the differentiation of any function? Yeah. So let's see the example. Find the differentiation of x squared by using the first principle method. So in this case, if we see the definition, we have to find fx plus delta x and fx. So we have to find fx plus delta x is x plus delta x squared, because fx is x squared. And we can expand this, become x squared plus 2x times delta x plus delta x squared. So if we use the method, this is a limit for delta x approach to zero, fx plus delta x. So this is x squared plus 2x times delta x plus delta x squared minus with fx. So minus with x squared divided by the delta x. So in here you can see that limit for delta x approach to zero, you will have, we can cancel the x squared there. So we will have 2x delta x plus delta x squared over delta x. Now, if we substitute the value of the delta x, which is approach to 0, to the equation, you have 0 over 0. So this is undefined. So that's why by using the limit function, we can simplify the delta x by factorization. So we have 2x plus delta x over delta x. And now we cancel the delta x and substitute the delta x approach to 0 to here. So it will equals to 2x. So from this definition, from this first principle method, we can see that if we have y equals to x squared, the function y equals to x squared, the graph is y equals to x squared. So the derivative of the differentiation of the function y, x squared, is equals to 2x. Yeah, by using this method. So this is a differentiation. How you derive the function to get the dy dx, the derivative. Yeah, so if we have x squared, we will have the differentiation of 2x. Okay, let's see example number 2. Find the differentiation of x cubed by using the first principle method. So the same. That means we have to find the fx plus delta x. So this is x plus delta x cubed. So we need the help of binomial expansion. Yeah, we learned this already. So we have 3c0 x cubed plus 3c1 x squared delta x plus 3c2 x delta x squared plus 3c3 delta x cubed. So if we simplify, it becomes 1 times x cubed plus 3 x squared delta x plus 3 x delta x squared plus 1 times delta x cubed. So if we use the first principle method, so this is limit for delta x approach to 0, fx plus delta x. So we copy this, x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed over delta x. Now we simplify. So this is minus with x cubed, yeah. So we cancel the x cubed. So we have 3x squared delta x plus 3x delta x squared plus delta x cubed per delta x. Now we can factorize. So delta x, 3x squared plus 3x delta x plus delta x squared over delta x. So you can cancel this. And when you replace the value of x, delta x, so this will be 0, this will be 0. So the remaining is the 3x squared. So again, in here, we can find the pattern. So if we y equals to x cubed, So the first derivative of the curve is 3x squared from here. Now, okay, the same thing, yeah? So we have to find x plus delta x. So it's x plus delta x squared plus 2 delta x plus delta x plus 3. So dy dx is equals to limit delta x approach to 0 from fx plus h equals to, so we have to expand, yeah, expand the first equation, become x squared plus 2x delta x plus delta x squared. Yeah, we expand from here plus to this. So 2x plus 2 delta x and then plus 3 minus with fx. So x squared minus 2x minus 3. Yeah, this is minus because of the negatives. Yeah, so if you put bracket, so it is still a positive as well as the function over delta x. Okay, in here we can see that we can cancel the x squared and we can cancel the 2x and 3. So the remaining are limit x approach to the 0. So 2x delta x plus delta x squared plus 2 delta x over delta x. So we can factorize delta x approach to 0. So we can factorize this. So delta x, it's 2x plus delta x plus 2 over delta x. So cancel this. And when I replace the delta x to 0, so I have 2x plus 2. So this is the correct one. So from here, again, if y equals to x squared plus 2x plus 3, so the derivative of y with respect to x is equal to 2x plus 2 from here. So that's how do we find the differentiation using the first principle method. Now, if you notice, if we have x squared, we will have the derivative as 2x. If we have x cubed, the derivative will be 3x squared. And now, if fx equals to x squared plus 2x plus 3, the derivative is 2x plus 2. So we can see a pattern here. From x squared to become 2x. So the pattern is the power is being multiplied. And then you minus the power by 1. See, if we see the 2x, this is the 2x to the power of 1. So 1 times 2 is 2. And then x to the power of 0, which is 1. Let's see again. So y equals to x cubed. So dy dx is the x cube. The cube number is multiplied to the number in front. So it's become 3x. And then the power u minus 1. So 3 minus 1, it becomes 2. So that's the pattern. So from here, for the algebraic fraction, we can conclude that for y equals to ax to the power of n, so the derivative of the differentiation of that kind of equation will be equals to a times the power times n and times the x the power minus 1. Yeah. So let's see the example. Find the dy dx of the following function. So if we use the formula, so 3x squared, 3x squared, so the 2 is multiplied by 3. So dy dx equals to 3 times 2 is 6. X, the power is minus 1. So 2 minus 1 is 1. Minus 4x. So this is the power of 1. So 1 times 4 is 4. And then x to the power of 0, which is 0. So that's it. This is the differentiation of algebraic fraction. Let's move on to different examples. Now find the dy dx of 2x plus 1 times 5x minus 4. So first, to make this into this form individually, so we have to do the expansion. So we expand, this becomes 10x squared minus 8 plus 5, so it's minus 3x, and then minus with 4. So the dy dx, now it is satisfy this expression individually. So we can derive it individually. So 10x squared, it's 10 times 2 become 20. X the power n minus 1. And then for the 3x, so 3x to the power of 1 times 3 is positive negative here. Negative 3 x to the power of 0. So this one is the first derivative. Y equals to 4 square root of x. So we can change it into 4x to the power of half. So that means dy dx is equals to 4 times half. So it's 2. And then the power is minus 1. So 2x to the power of negative half. Number 4. Y equals to 6x squared plus 5x over 3x4 plus 5x. So we have to split the first fraction. We simplify it into 6x squared over 3x4 plus 5x over 3x4 plus 5x. Or it is equals to 2x to the power of 2 minus 4 is negative 2 plus 5 over 3 x to the power of 1 minus 4 is negative 3 plus 5x. So the first derivative dy dx is equals to, we multiply the negative 2, so it's negative 4x, and then we subtract by negative 1. So it becomes negative 3. Plus, we multiply the negative 3, it's minus 5x, and then we minus 1, the power, it's negative 4, plus 5x is x to the power of 1 times 5. So this is 5. And we simplify, negative 4 over x cubed minus 5 over x4 plus 5. Yeah, this is the answer. So we have to simplify the expression into the form of the general ax to the power of n. That's why we have to split this fraction into individual terms. This is the exercise you can do by yourself as a practice. And this is the end of the part 1 video. I will continue the second part about differentiation of ln and exponential, and then continued with the rules of differentiation. So stay tuned on the next video, and thank you. Bye-bye.